All right, Milo, go ahead and read the first two sentences on the top right here.
Sounds good. The equation y equals 3x squared minus 7 equals 5 is expressed in explicit form. The variable y is explicitly written as a function of x. The equation y cubed plus x cubed minus y squared minus 5y minus x squared equals -4 is an implicit equation, and it will be very difficult to rewrite it in a form where y is the text.
So here's my summary. Explicit means y is by itself. Implicit means y is not by itself anymore. Can we actually see that? That's it. Just sounds a little fancy. Okay? So on the bottom on the next one right here, Landry, go ahead and read this paragraph, and I will simplify it.
In order to take the derivative of an implicit equation, you must use implicit differentiation. When finding dy over dx implicitly, you must realize that the differentiation is taking place with respect to x. When you differentiate terms involving only x, you can differentiate as usual. But when you differentiate terms involving y, you must apply the chain rule.
All right, all that makes sense, right? Here's my summary to you. So far, we have been differentiated with respect to the x, just the x's, right? Everything was x, everything was x. Today, I'm going to go ahead and incorporate the y. What that basically means, anywhere I see a y on our number 1, I want you to go ahead and highlight it or circle it, because something else happens with this. And I'm actually going to prove to you with the graph when I'm done. So if you're a little confused, just hold on to your questions. So did everyone highlight or circle the y values? All right? Anytime, so here's our step number 1. At some point today, or even next time, you might not need any steps, because really in the end, it's algebra 1 after step 1. So anytime you are dealing with the y, you are going to multiply by dy dx at all times. And the reasoning for that is, if we are finding dy over dx, don't I need to see that in the equation at some point? So I have to add it at some point. So here I go, Sam. Open your eyes. Let's go ahead and find the derivative of this implicit differentiation with respect to the x. So we're going to do the same thing that we've been doing. What is the derivative of y cubed? 3y squared. Anytime I mess with the y, what do I add at the end? Dy dx at all times. The next one, what is the derivative of x cubed? 3x squared. And those of you guys participating, I do appreciate you. Our next one, negative y squared, how many? Negative 2y. What do I need to go ahead and multiply that by? Dy over dx. The next piece, then we have negative 5y is minus 5, and that's dy over dx. Just sounds fancy since we're adding a lot of letters. What is the derivative of negative x squared? Minus 2x. And derivative of any number is 0. So now, step 2. We are going to factor out dy over dx. And the reason is, at some point, we have to make dy over dx by itself. And for that to happen, we have to factor. So I'm going to use my highlighter so I can locate where they are. I see dy over dx stuck over here. I see it stuck here. And I also see it stuck here. So if you're a color person, please use it. So here I go. Let's take out dy over dx. Open your parentheses and put all the other values in. Right, Xavier? 3y squared, keep writing. Minus 2y minus 5. And then what I'm going to do is, since I know I have to make dy over dx by itself, I am going to move this and move this to the other side of the equation. And we know that according to algebra 1, we have to do the opposite, minus 3x squared plus 2x. So what I did right now was algebra 1. So step number 3, which is our last one, we are going to divide it by everybody that's inside the parentheses. Do I have all the parentheses right here? It's being multiplied right now, so we know we are going to divide. So here I go. Dy over dx is equal to what I have on the other side over the parentheses that I'm moving. Oh, I put a plus instead of a minus. Hopefully you did the minus. So we have minus 2y minus 5. And that is our final answer. So yes, it looks messy, and yes, it is simple because in the end you're doing algebra 1. So I'm going to go ahead and prove the next step for you. If you don't want to write this piece, don't. You don't have to. Because I know a lot of you guys are like, okay, we did all that. What does that mean? This right here is a slope function. We all know that, right? Taking a derivative is a slope function. Oh, I didn't spell that right. Function. And here's my proof. I'm going to pick a random point on here and go, you know what? I'm going to go ahead and pick this point and make a tangent line through that point. Again, you don't have to write this point or this piece. And my approximation of this point is about 1.5. If you want to argue and say 1.4, I agree with you. About 2.2-ish. That's our x and y. So just by looking at this, is my slope positive or negative? Negative. All right. Let's see if I have it already typed in. No, I don't. Dang it. Okay, go ahead and look at my screen, and you tell me if I'm doing anything silly, as in typing in the wrong thing. Here's my slope function. I'm going to plug in 1.5 for the x, 2.2 for the y. So my alpha y equals -3. We have 1.5 all squared plus 2 times 1.5. Okay, did I mess up on the top? Okay, on the bottom, we have 3 times 2.2 squared minus 2 times 2.2 minus 5. Did I mess up on the bottom? All right, so our anticipation is a negative slope. Did I get a negative slope? Boom, just proved it to you. So even though at the beginning was like, none of that makes sense, I think the proving is enough on this one. So let's go on to the next page. Okay, on our next page, we're doing the same thing except we are going to incorporate product rule. And I'm going to get rid of this because I want to go ahead and formally write on here d over dx. So let's go ahead and take the derivative with respect to x. And notice we have a product rule. Let's go ahead and put that in parentheses. All right. Are we all ready? Okay. The product rule says we derive the first one. What is the derivative of 2x to the power of 6? 12x to the 5th. And we keep the second one. Now, when I kept the second one, did I mess with that number at all? So we're not going to add dy over dx. It's only when you're deriving it. Then I have plus, and then we keep the first one. What is the derivative of y to the 9th? 9y to the 8th. And then we have to add dy over dx. Well, we can't solve for that. Close it. So the product rule is done. What is the derivative of 3x? Just 3. What is the derivative of negative y to the 3rd? Negative 3y squared. And then we had to add dy over dx. And I know it says 2 cubed on the other side. That's still a number. A number derivative is 0. So now let's go ahead and box off where my dy over dx's are so I can go ahead and organize it. Some of you guys might be able to do this without showing any work. At some point, we're going to get there, but not today, all right? But if you want to, do it. Nothing wrong with it. Let's go ahead and factor out dy over dx and put everybody in the parentheses. And on the parentheses, I'm going to do something. 2 times 9 is 18. I'm going to go ahead and put them together. Then we have x to the power of 6, y to the 8, minus. The other one has 3y to the power of 2. Close it. And let's move this one and this one on the other side of the equation. Minus 12x to the 5th, y to the 9th, minus 3. And what is our last step? What operation? Divide the whole thing right here. So I'm going to copy the right side, as I already have on my numerator. And then my denominator is what I'm dividing by. And again, this is our slope function. So let's write out, it is our slope function. Since I proved it to you on number 1, do I need to go ahead and plug this back in on the calculator?
No.
You guys trust me?
Yes.
Oh, goodness. I like that. All right. Even though I think it's still making us do it, right? Find a slope at this point, x and y. And I want to actually graph this. If you guys can tell right here, it's really not a horizontal line. It's ever so slightly going up in a positive direction. It's very slant. So we have the slope is going to be some positive number. And it's going to be a fractional number, obvious, because it's very, very shallow. And when they're asking us to find a slope, here's what you have to do on the AP test. Listen up. Plug in the x, plug in the y, physically with your pencil. So we have negative 12 times a 0 to the 5th. Negative 2 to the 9. Again, we're just plugging it in. So I don't think I want to say the rest of the piece. Plug in 0 and negative 2. All right. And because of the number 0, this is going to look easier than it looks. When we are multiplying something by 0, what does that make all of that? Nothing and nothing. So really in the end, we have the top is negative 3. What is my bottom going to give me? Negative how many? No.
Is it not? Wait.
Negative 2 all squared is 4. Negative 12. My kids are struggling at multiplying. All right, we're going to be all right. All right, so here's my slope. So let's go up here. So the slope is very, very shallow. It makes sense that we have 1/4. Jameson got excited. It's like, she's just going to complete her sentence. Kind of like when you're excited, you don't know what to say. I think that's what it was. All right, the last portion for today. Are we all paying attention? Yes? All right, last portion. Write the equation of a tangent line. So let's go ahead and write x and y. Tangent line, I must have a slope. Didn't I already find the slope already? So let's write out our equation. Y minus y1. This is going back to our algebra. M times x minus x1. Xavier, you're just crunching. Okay. You're writing though? So we have y minus the 2. That's going to be what? Plus 2 is equal to 1/4 times x minus 0. And I'm going to leave that just for teaching purpose. If you also give me, because I know on your last test, a lot of you guys went all the way and you still had it correct. If you go all the way and solve for y, either or will work. Take the derivative, and I think I'm going to rewrite this. Let's write out cosine, of 2y is equal to x. And we are going to take the derivative, always respect to x. So, would this, the left side be a chain rule in the end? Function within a function? What's the derivative of cosine? Negative sign, keep the inside. And the derivative of the inside is 2. Now, we derived something that had to do with the y, so what do I have to multiply by? dy over dx. Otherwise, I can't solve for dy over dx by itself. What is the derivative of 1x? 1. So our goal is to make dy over dx by itself. And it looks like all we need to do is divide it by whatever remaining. So let's write out dy over dx is equal to 1 all over. And I'm going to move the 2 with the coefficient of the negative 1. You don't have to, but I want to make it neat and organize it. And that is our slope function. That was easier.
Wait,
What's up?
how do you know to put the dy over dx?
Anytime you are deriving anything with the y, which I did, derivative of 2y is 2, you have to go ahead and multiply by dy over dx.
Oh, okay.
If it has to do with the y, add that on there, okay?
Why is it equal to 1, 0?
The derivative of 2x is 2. So derivative of 1x is 1.
Oh.
Okay? All right, moving on to number 4. On number 4, how many times is it asking us to derive this? Twice. So let's kind of remind ourselves from unit 1 with the notation. The notation really doesn't matter today, but I want to go ahead and talk about it as a reminder. The derivative is y prime. And another way we look at this, Josiah, I'm up here, not on your screen, is dy over dx. And if y'all remember back in like 1 point how many, the derivative of, or second derivative was notated by the following. D squared y over dx squared. And these are just given fact. If you go, why is it that way? Whoever made it decided to keep it that way. So that part we're just going to leave, all right? So here's our goal. And I'm going to start by rewriting the circle equation. You guys actually know this is a circle? Circle with a radius of what? 5. All right. So your geometry teacher was awesome. All right, so let's go ahead and derive it with respect to the x. What is the derivative of x squared? 2x. And then what is the derivative of y squared? Now, anytime you derive something with the y, we have to say dy over dx. Because at some point we have to solve for that, so it's got to be that. And the derivative of any constant is what number? 0. So then I want to go ahead and make this one by itself. And I think we can do one go in algebra 1. So dy over dx is equal to, I know I need to subtract 2x on both sides, and we also need to divide it by 2y on both sides. Can I eliminate something here?
2.
Yes, I can. So I'm going to write out r dy over dx is equal to negative x over y. So let's go ahead and draw a line for my second derivative. So I'm going to write out, right now I have dy over dx is equal to negative x over y. And yes, I am going to derive this with respect to x again. And when I take the derivative for the second time, this is a notation that I need to write on the left side. Whether you disagree with this or not, we have to write it this way. Because I know some of you guys are going to argue, because I would too. You might go, hey, I see double d's and double x's on here. So do I need a squared on that one? No. According to our derivative powers, we have to leave it like this. Okay? So if you're like, I'm not happy with it, I apologize. So I have quotient rule. So what do I do on the bottom? Square. It is separated with the minus sign. So derivative of the top is -1, and we keep the bottom. Keep the top. What is a derivative of 1y? 1. And that was pertaining to the y, so I need to add dy over dx. And really, in the end, it looks like our answer is almost there. Oh, yeah, it is. Do we see that we have dy over dx right here that I can plug in instead? Yep, let's plug it in. So when I plug that piece in, I get, I'm going to copy everybody the same. And then just a dy over dx for the first one gave me negative x over y squared. And no, you don't have to simplify this. And this is our final answer.